Okay, the last handful of problems deal with our library of functions. You need to review that. We will be reviewing that before Friday's test. Only one of the following graphs has a zero, right? Zero of a function is one where the graph touches the x-axis. Y is equal to 3. No, that's a horizontal line right up here, so that's not it. This is the square root function with upward shift of 1. So you know what the square root function looks like that. That does have a 0, but when you shift it up 1 unit, it does not. So that's no good. This is an, let's see, an upside down parabola, but it's shifted down 1 unit. So let's get a little sketch of that going. Most of these you can just do in your head. Y equals minus x squared is this graph right here. And this is y is equal to minus x squared. And what we're supposed to do with that is to drop it down by 1 unit, right? So minus x squared, and then drop it down 1. This will come down to there, okay? And so obviously not having a 0, no x-intercept. Okay, e to the minus x, that's one of our exponential decay curves. And as we mentioned before, no exponential ever gets to 0, so that's not right either. The natural log of x shifted down 1 unit, that's going to be our correct answer. So let's see, the natural log of x, which you should be comfortable with by now, looks like this. If we shift it down 1 unit, it would come down like this. I can't get my curve to move, but sure enough, we have a 0. That is the correct answer. This is a parabola shifted up 1. That's not it. This is our exponential growth shifted up 1. This is the absolute value shifted up 1. None of those have zeros. Okay, problem 80. Of these 12 functions, only one has a domain of, let's see, this says including 0 and going out to positive infinity. So these would be the positive numbers and 0. So let's see, this first choice, the square root function, is in fact the right answer. You should know what the graph of that looks like. The square root function starts at the origin and travels out like that. Okay, so the domain is in fact going from 0 out to positive infinity. Those are the allowable x values, okay, including the origin. This has a domain of all reals, so does this. So those are out. This has the domain of all reals, so that's out. The 1 over x squared, the reciprocal function, you should know pretty easily. That's this one, this rectangular hyperbola. The 1 over x squared takes this piece in the 3rd quadrant and moves it up to the 2nd quadrant, and the shape changes slightly. We're going through the 0.11, and instead of 2, 1, it's at 2 1/4, right? And the same thing over here. But at any rate, that is not the positive numbers. That's out. And the natural log, again, does not include 0. So here's a log graph. It does not include 0. Remember, the natural log of 0 is undefined, so that's out as well. Choice A, square root. Of these functions, many are even or odd, some are neither, which is neither even nor odd. Now again, remember the idea of symmetry, either about the y-axis or about the origin. This is odd. This one is even, right? The v, this is even. The exponent gives it away. This is odd. This one, what's going on there? Well, we just looked at the graph. That was this, right? So that is one that is neither even nor odd. That is the correct answer to this problem. If we check these other ones, this one is odd. This one is neither, right? The natural log graph looked like that. That's neither even nor odd, but that wasn't one of our choices here. So even though it's neither, it's not the answer to this question. The exponential growth and decay, those are neither even nor odd as well. Here's the growth curve, right? Not symmetric about the y, certainly not symmetric about the origin. Here's the decay curve, going this way, not symmetric about y, not symmetric about the origin. So both of these are neither, but they were not choices of the 6 that we had here. Y equals 3, that's an even function, right? 1, 2, 3, looks like that. Y equals 1 over x, that's odd, and 1 over x squared, that's even, right? So yes, know all of these functions. We're going to be adding, remember, other functions as we get into the second semester, the sine wave, the cosine wave, tangent graph. So make sure you know the ones you're supposed to know right now before we add additional ones. Okay, 82. Of these 12 functions, many pass through the point 1, 1, which the following does not. Okay, well, the square root curve, certainly we know that goes through 1, 1. The square root of 1 is 1. Okay, e to the x, that's our growth curve, right? Going like this. In fact, it passes through the point 0, 1 when x is 1, right? Y is e to the x. When x is 1, we're up at this point e. And this is about 2.7-ish, right? So that's the one that does not pass through 1, 1. The cube root function, very similar to the square root function. Cube root function looks like that. Okay, goes through 1, 1. The 1 over x squared, we looked at that. That certainly goes through 1, 1. Y equals x cubed, that does, and the absolute value does. Okay, so the one that does not is the exponential choice B. 83, this was our bonus. So I had 3 or 4 people get this successfully. I gave you a hint on how to do it. It said use a conjugate and multiply it by the number 1. You know, you can take any expression and always multiply by 1. So we're given this expression, 2c over minus b minus plus the square root of b squared minus 4ac. And what we're going to do is we're going to multiply this by the number 1. It will not change, but it will change its form. Now, what form of 1 do we want? We want the conjugate, right? So remember, from either complex conjugates or trying to get a irrational denominator taken care of, the way you get a conjugate is you leave the first part alone and you swap the sign. So instead of minus plus, this is going to be plus minus. So that's how conjugates work. And because this whole expression has to be 1, we need the exact same thing here. And I think everybody would agree that this blue expression is equal to 1. Anything divided by itself is 1. Now, what happens when you do that? Okay, so a little bit of algebra. Let's look at the bottom part first. The bottom is nice. When you multiply these out, let's see, negative b times negative b is going to be a positive b squared. The middle terms will drop out, right? Because that's what happens when you try conjugates. If you want to try this, this is negative b times plus minus. So that would be minus plus, and there's a b and there's a radical. But when you do this one, right, the inside, you get minus plus times minus, and that would be plus minus b radical. And those, in fact, will drop out, right, because the opposite signs. But the last term, right, conjugates, the first and the last is all we really need to deal with. The last is interesting. Let's see, we have a radical times a radical. So that's going to take care of the radical. We simply get b squared minus 4ac. What is the sign of that? Well, let's see, if we're using the tops, let me do this in black, we have a negative times a positive. Well, that would be a negative. If we do the bottoms, we have a positive times a negative, which is still a negative. So we get that. So here, in fact, is our denominator multiplied out. So we've got b squared minus the quantity b squared minus 4ac. Okay, and how about up top? Well, top isn't too bad. We just have to distribute the 2c times the negative b. We can do that in the 2c times the radical. So let's see if we can clean this up a little bit. Oh, there's our denominator. Here was our numerator. We get minus 2bc and then plus minus 2c times the radical b squared minus 4ac. Okay, so that's using the conjugated idea. And then let's see what that, remember what this is supposed to equal. It's the good old quadratic formula that we're familiar with. Up top, well, let's do the bottom first. The bottoms, the b squares go out and we just get 4ac. And b squared, take away b squared is 0, and minus minus is plus. Up top, we have two terms. And in fact, I'm going to factor these. Let me factor the 2c out of the top so that I simply have a minus b plus or minus the square root of b squared minus 4ac. Like that. And then it's useful that I know where I'm supposed to be headed. At that stage, I'll cancel. So the 2 goes into the 4 twice. The c goes out. And we're left with exactly what we expect, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Yay for those that did it. Okay, well, that's the end of our exam. No, you won't see this fancy quadratic formula on Friday, but you better know the one you learned in Algebra 1. Happy second semester.